How are you doing? We're going to talk about my last research. We have been working in some constructible sets. So you might wonder what a constructible set is. And I'm going to tell you. A set is constructible if it can be obtained as a finite union or a finite intersection or the complement of some initial family. Think like this. You have a family of sets. Those are subsets of some universe, right? Okay, so you take the union of two sets at a time, or the intersection of two sets at a time, or the complement of one set at a time. Suppose that you start with the open intervals, or the closed intervals, or the open subsets of the real numbers, or finite subsets. And then you form these families through these operations and through these rules. Remember, taking two at a time. So, let's say that you start with the open intervals. What happens when you go one step? In other words, if you start with this family and you do these operations and following these rules, what do you have? You have a nice family, a first family. And then if you start with this family and you do the same operations, you have another family. And then another family, and so on and so forth, until you have the last family that consists of the union of all the possible families that you can construct during this process. This construction process deals with algebras, sigma algebras, and topologies. In fact, in topology, there is the concept of separability that says that if you have two elements, there is a subset of the family that contains one element but not the other. That concept is T sub 0, the first axiom of separability. Well, therefore, that interesting concept can be extended through a general family of sets, and we call it separable. So that concept of separability is very close related to partitions, and those two concepts play together a beautiful role, generating marvelous results in our theory. We deal with topology, we deal with sigma algebras and algebras. And in fact, the connections that we have and the results that we have can be applied to topological spaces. For example, we talk about locally closed sets those are finite intersections of open and closed sets. Those locally closed sets are just a particular case of our constructible sets. So this theory deals with all this construction. In addition, you can say how many steps does it take to build the whole family. Does it take a finite number of steps? Under which conditions you can achieve the last family within a finite number of steps? That's a very interesting question. We address this question and we work with minimal constructible families. A family is minimal constructible if there is no subset, there's no element in the family that can be constructed from the union or intersection of the complement of the other elements in the family. So all this forms part of our research. The people have worked with me in the summer through summer research programs, and a master student who did his thesis in this topic have put together all this collection of nice results, and we are sending them for publication. We hope that it gets accepted, and that's what we're doing right now. Thank you.